Okay, good afternoon, everyone, and welcome to our 2021 training series of webinars. I'm Shirley Lamb, and I coordinate the National Building Control Office training. We work with building control authorities, owners, designers, builders, and suppliers of construction products to promote compliance with the building regulations. Product suppliers have a vested interest also in ensuring that their products are used correctly in the construction process and not damaged. And where we find damaged or misused products during our site visits, we are now informing suppliers and manufacturers of these products, who in turn are encouraged to promote compliance. The mission of the National Building Control Office is to promote a culture of compliance with the building regulations in an industry marked by rapid changes in technology and processes. We do this through 5 pillars: compliance support, education and training, which is what we are doing today, inspections, our BCMS system on localgov.ie, and market surveillance of construction products. The building control legislation framework within which we work includes the Building Control Acts 1990 to 2014, the Building Control Regulations, the Building Regulations Parts A to M, the European Union Construction Products Regulations and associated market surveillance, and the European Union Energy Performance in Building Regulations. To promote compliance with the building regulations, we support building control officers in the 31 local authorities who are continually inspecting for compliance with the building regulations and building control regulations. Inquiries can be made to the relevant building control authorities or ourselves here at support@nbco.gov.ie or to the department at buildingstandards@housing.gov.ie. I would ask that you use the Q&A function throughout the webinar. The Q&A will then be provided under the video description or the comment section of the video on our YouTube channel, NBCO DCC. I will now hand you over to Dermot Kearney of ICANN Acoustics, who will speak on Part A of the building regulations. Thank you.
That's great. Thank you for that, Shirley. Indeed, I'll just share my screen with you now. Bear with me 1 second. Okay, you should be on your screen now, Shirley, is it? Or
yeah, it's there.
Yeah, that's great. Okay, so look, firstly, I'd like to thank the National Building Control Office, effectively, I suppose, Shirley Lamb, Mairead Phelan and Éanna O'Canela for organising today's presentation. The title of the presentation today is Sound Insulation Testing and Interpreting the Requirements of Technical Guidance Document E 2014. Just a little bit of housekeeping and a disclaimer. We just ask that all participants would keep their microphones muted throughout the presentation. The presentation will take circa 45 minutes with the questions and answers session at the end, time permitting. The presentation essentially today is designed to be informative, and it's not an alternative to Technical Guidance Document E. So I suppose Technical Guidance Document E remains the overriding document to be consulted in all cases. Also, as Shirley quite rightly pointed out, in terms of your building control officers, always consult with your building control officer or your appointed professional if there's any uncertainty about any elements within Technical Guidance Document E 2014. Okay, so an introduction. My own name is Dermot Kearney. My company is ICANN Acoustics. We're located at acoustics.ie. I hold an MSc in Applied Acoustics from the University of Derby, as well as that a diploma in Acoustics and Noise Control from the University of Ulster, and a BE from NUI. I'm a member and chair of the Association of Acoustic Consultants of Ireland and the Institute of Acoustics in the UK. Some of our clients throughout Ireland, it's an old list at this point, but just some of the people we work with in various elements relating to acoustics and sound insulation testing and so on. Okay, so I'm just going to present to you two slides that set out a framework to be used in terms of the application of Technical Guidance Document E. There's quite a lot in those slides, and I wouldn't expect to go through them and read them all, every single element within them, but just some key points. E1 relates to sound, and obviously, the testing of walls and floors and separating elements between dwellings. The part E2 in 2014 Technical Guidance Document E deals with reverberation. And again, this relates to common areas, internal areas within buildings. And obviously E3 then deals with definitions. Now, I'm not going to go into them in any huge detail. This slide has an awful lot of information on it, but I just want to give you this slide because I think it'll be important. This session is going to be recorded and it'll be there for you to reference. Again, we're dealing specifically with Technical Guidance Document E 2014. There was some previous editions of that, which was 1997, which was reprinted in 2005. And obviously prior to that, there was a 1991 Technical Guidance Document E. Again, this is another slide, a lot of information in it. I'm not going to go through it in any huge detail, but it just sets out the framework in relation to the building regulations and the applications of them. And I just include it there so that it's in the video as well. Okay, so Technical Guidance Document E, or the Irish Building Regulations, TGD E 2014, on-site testing. And this is what I'm going to talk to you about today. So generally, in scenarios where we're dealing with semi-detached dwellings or indeed terrace dwelling, we're looking at horizontal tests. Now, if you look at that picture on screen at the moment, we say one semi-detached dwelling on the left and one on the right. So we're interested in sound transfer across the party wall or the separating elements of that property, both at ground floor level and at first floor level. And in theory, if the attic was converted, you would be looking at potentially sound transfer issues in that attic space as well. But just for now, let's deal with just the ground floor and first floor. When it comes to apartments, then we're obviously interested in horizontal performance or horizontal sound insulation tests, but we're also interested in vertical elements. If you look at that arrow I have on screen, we're interested in sound transfer between, we say, this apartment here, the one directly above it, or vice versa, sound transfer, airborne sound transfer from this apartment to the one below. We're also interested in impact noise and the transfer of that via floor. So again, just to keep in mind, with semi-detached dwellings and terraced houses, we're generally looking at horizontal tests, but with apartments, we're looking at both vertical tests and horizontal tests. So we're interested really in evaluating the sound insulation performance between apartments, either horizontally or indeed vertically. So you can see straight away there from those few arrows, those 4 arrows I have there, that when it comes to apartments, we're interested in sound transfer in more directions than just the horizontal direction, if that makes sense. Then when it comes to duplex arrangements, obviously we're interested in this separating element between, we'll say, the property on the left of that line and the property on the right of that line. But what is important with duplex elements is the ground floor is also a residential unit, and we're also interested in sound transfer vertically in that particular arrangement as well, and indeed horizontally between, we'll say, this dwelling here and the adjacent one as well. So I just put in arrows just to show you. Obviously, we'd be concerned about airborne noise and impact noise, which I'll get to in a few slides on. But again, we're interested in the separating element between those two dwellings. And again, same would apply. We're interested horizontally in the separating element between these two dwellings and so on. So just to understand that in terms of the different types of properties that are tested, you can have, as I say, semi-detached, you can have terraced, you can have duplex, or you can have apartment arrangements, and there's different testing protocols for all of those different types of buildings. Okay, so there's 2 types of tests. There's airborne tests and impact noise tests. Now, just to explain airborne noise tests, and these are carried out on walls and floors. So airborne noise, just as an example of airborne noise, if you're in a residential property and you can hear voices from an adjacent property, or you can hear the TV or the hi-fi or shouting or singing or loud speech and so on, that's an example of airborne noise. Now, keep in mind the building regulations in the UK were originally where they originally sort of stemmed from, were there really to protect people against loud speech. But just to give you a little bit of context about where they sort of emanated from originally. Now, keep in mind, in terms of the level of transfer or the sound transfer between two adjacent dwellings, the building regulations, the concept of having obviously soundproof is quite difficult, and perhaps you wouldn't do it with a semi-detached dwelling or indeed an apartment building if you did require a very, very high level of sound insulation. So again, just that might help in terms of understanding the context and where they emanated from as well in the UK. The other type of noise transfer then we're looking at are impact noise tests, and these are carried out on floors. Some examples of those, if you're ever in an apartment building and you hear footfall from the floor upstairs, or indeed footfall in corridor areas, you can have impacts on floors. Somebody dropping a jar in an apartment, for example, on a hard floor surface, it induces vibration into the structure and it'll carry through the structure. Another example of that is the dragging of chairs, being able to hear that in the apartment directly below, and even in adjacent apartments, you can sometimes hear that because of the fact that they're all sort of structurally connected, if that makes sense. This is a diagram taken directly from Technical Guidance Document E, and it's useful. It's similar in terms of what I showed you earlier in terms of the picture. You can see, for example, they're concerned about any dwelling and the separating element between that and an adjoining dwelling. Now you can see there's a little circle with A for airborne noise test, or airborne sound insulation, and I for impact sound insulation. So you can see, for example, I'll just show you with the mouse, you have any dwelling and there's concerns about airborne transfer vertically and indeed impact noise transfer vertically. And the other thing I should point out is that there's also in most cases concern then about obviously transfer between the dwelling and any other parts of the same building. So again, that diagram is useful in terms of, I suppose, understanding the requirements in terms of both airborne noise and impact noise as well. Okay, so the measurement kit. So when we're carrying out a sound insulation test, what do we use? Well, for airborne sound tests, we use a speaker called a dodecahedron speaker. It's basically an omnidirectional speaker that generates, with an amplifier, generates pink noise and fills a room with pink noise. It's essentially a test signal that we use to carry out a sound insulation test. We also use an analyzer or a handheld sound level meter with a software on it to deal with sound insulation tests specifically. And indeed, we have an amplifier and signal generator to run the dodecahedron speaker. When it comes then to impact noise, we use a device called a tapping machine. And this is essentially a device that's placed on the floor of an apartment and where it runs and it generates impact noise or induces impact noise into a floor. And I'll deal with that in a little bit more detail in the next couple of slides as well. So let's just look at an airborne sound insulation test. These are, you're essentially looking at two dwellings side by side. That split line you see down the center is the separating element between those two apartments. And if you look in through the window there, I've set up our dodecahedron speaker on a stand. And obviously what I want to highlight here is that always there is a source room involved and there is a receiving room. So as part of the tests across a party wall or indeed a separating element, you're dealing with a source room always and a receiving room. So in terms of the sound insulation and sound transfer between those two rooms, It's important to realize that you're dealing with direct paths, and that's sound that travels directly through the wall. Now, keep in mind, direct paths are only one element of the sound insulation test. The sound insulation test is a room-to-room test. So it measures both direct paths and indirect paths. So you need to keep in mind that even when you generate noise in the source room, you'll obviously have a certain amount of noise that'll break through the separating element, but you'll have noise that'll flank over the separating element, under the separating element, and around the separating element. So keep in mind, it's a room-to-room test, and it consists, the performance is made up of direct paths and multiple indirect paths. So it's the junctions as well as the wall itself. And you'll notice technical guidance document E 2014 is very good on that, and it's very strong on that in terms of it defines the wall buildup, and indeed there's a lot of attention paid in relation to the junction detail, because it has realized the importance of the junctions, and in terms of the flanking, they're called flanking paths, and how sound travels both through the separating element and around the separating element. Then when it comes to apartments, it's the same situation. When you're carrying out a sound insulation test in an apartment, again, you're dealing with a source room. And if we take this sample here as being a source room, and again, above it, we'll say receiving room. So you can test in that direction or vice versa. Again, there's protocols about the direction of test and so on, which I won't have time to go into in this particular presentation, but just keep in mind, you're always dealing with a source room and a receiving room. And again, with that, you're concerned about, we'll say, for example, in terms of an airborne test in this direction, you're concerned about transfer via the floor slab, but you're also concerned about, you should be concerned about flanking paths, sound that travels around the floor or through. For example, if you look at this curtain wall detail, again, when you carry out a sound insulation test between those two rooms, there will be direct paths and there will be indirect paths. So that's paths that will flank around the actual floor element as well. So you can just see in a situation like this, the importance of that junction detail would be critical. Now, that's not a junction detail in technical guidance document E, I should point out as well. But just the reason I use that sample really is just to show you that the junctions are as important as the separating element. So they should be considered very carefully. Now, not only in apartments, then you're concerned about obviously vertical transfer, but you should be concerned about horizontal transfer as well. So suppose this is that source room is one apartment. You may have an adjacent apartment over here. I'm showing you with the mouse, if you can see that on screen. So again, you need to be concerned about horizontal transfer and the junction detail there as well. Now, again, as I said to you, this detail is not in technical guidance document E, but I think it's a good one to illustrate flanking paths and the potential weaknesses caused by them. Okay, so again, always think there are direct paths and multiple flanking paths. In terms of impact sound insulation then, this is the close-up example of a tapping machine, and you'll notice it's got 3 feet and it's got 5 hammers, and I'll show you in a later slide how they work. But in fact, if I open this, this is what it looks like inside. So if I go back one slide, so that's it with the cover on. If I take the cover off, you can see that there are 5 hammers. They're half a kg each. They're inside in the tapping machine, and what happens is we place the tapping machine on the floor of an apartment at a certain location, and the hammers fall at a certain height. And I'm just going to play the video here just to show you how that works. So that the hammers strike, this is it in slow motion, the hammers strike the tiled surface. Okay, so you can see that the strike is repetitively. And the idea is that this tapping machine becomes a standardized source that we use to carry out impact sound insulation tests. I'll just run the video again there. So it obviously happens a lot faster than what you're seeing on screen right now, but the reason I've slowed it down is I just want to show you what happens. So if you can imagine, each time one of those hammers strikes the tile, it induces noise or indeed vibration into the structure. And the thing to keep in mind is that this tapping machine is built in accordance with a specific standard. So anyone carrying out sound insulation tests should be using a tapping machine that meets the type approvals, calibrated, and so on. And the idea being that if anyone was to carry out a sound insulation test, or another party was to go in there and repeat the test, in theory they should be getting the same results, in that the equipment should be identical in terms of its performance and how much, you know, noise or vibration it induces into the structure. So just in terms of impact noise tests, and just to explain it a little bit more. So that's the tapping machine. We place that on a floor, and what happens is the 5 hammers strike the floor and they induce noise and indeed vibration into that. It sets that floor panel into excitation, essentially. So what happens is, if you can imagine it, it induces vibration into it. Now that will also carry along the structure. And you'll notice that in most masonry buildings, for example, there's very good and efficient coupling between walls and floors and so on. So what happens is the tapping machine induces vibration into the structure, sets it into excitation. And what actually happens is those vibrating walls re-radiate that as noise. So again, we're in the receiving room. So just, and I'll come to it later, and this is important in terms of dealing with the metrics, but you can imagine if that tapping machine was off the floor, if I was to temporarily lift it off the floor, that the noise level would be a lot less. So the only reason I say that is it's important to differentiate between impact noise and airborne noise, and I'll explain that in a little bit more detail. But you can imagine, let's take this example. Suppose I was to put that tapping machine on a soft rubber mat. It would mean that the tapping machine is striking the rubber mat and not inducing as much vibration into the structure, and consequently the noise level will be a lot lower in the receiving room directly below. So to just keep that in your head in terms of the metrics, because it is important when it comes to discussing the metrics in Technical Guidance Document E, which I'll do in the next slide. So the standards and the metrics used. So you'll notice within Table 1 of Technical Guidance Document E that it sets out a minimum airborne requirement for walls and floors. And you'll see it uses this metric called a Dntw. But it suggests that the minimum should be 53. Now keep in mind, if I was to carry out an airborne sound insulation test, the higher the Dntw value, the better. So essentially, if I was to carry out an airborne sound insulation test and, for example, measured 48, it wouldn't meet that minimum. Whereas if I carried out repeated an airborne sound insulation test on another property and got a value of 60 dB Dntw, it would be comfortably above that minimum value. Now, in terms of impact noise, it's the other way around. If you recall, we're looking not to exceed a maximum of 58. And if I just go back to the slide earlier, if you think about a maximum of 58 and not exceeding it, a building that has a better resistance to, or a high resistance to impact noise, will result in a lower level in the receiving room. So that's essentially why the metrics, why with airborne noise, you're looking for a value greater than those stipulated, those minimum stipulated, whereas with impact noise, you're looking for the value not to exceed 58. So for example, if you measured 59 in your room, obviously the building is very efficient in terms of carrying impact noise into the room below. So again, that's the difference between the maximum and minimum. You're looking for a maximum in terms of airborne noise and a minimum in terms of impact noise. Now keep in mind, when we'll say carrying out a sound insulation test, and which I would remind you is a room to room test, we're carrying them out in accordance with a specific standard. And the whole idea behind using a standard like this one here, ISO 16283 Part 1, 2014, that deals with a specific standard in relation to carrying out an airborne test. So it means that if anyone, if somebody who's, I suppose, qualified to carry out a sound insulation test goes in to test a property and somebody else tests it 6 months down the line, in theory, once they're following the standard, they should get repeatable and consistent results. So it's very important that all the tests are carried out in accordance with the standard. So there is a specific standard in relation to airborne tests, and that's it on screen. In relation to impact noise tests then, where we measure the Lntw metric, again, it's the same standard number, but it's part 2, and it was released in 2018. Again, there's detail in there about, where the tapping machine should be placed, how you measure the number of measurements and so on. So there's very specific details, but the idea behind using a standard is that you can ensure that the results are repeatable and consistent. So the idea, if in theory, if you're using, 2 or 3 different testers, once they're following the standards, they should yield repeatable results, and that's the idea behind it. Okay, so I'll move on to the next slide. So in terms of the building regulations and how much testing needs to be carried out, well, there is a table 2 within the building regulations, and you can see there are 2 columns in there. And really, it's what it does show is it shows that for example, for dwelling houses, including we'll say semi-detached dwellings, and indeed bungalow dwellings that are, and again, we're always dealing with buildings that are attached and not obviously separate and independent buildings, just to make that clear. But it does set out that it talks about a minimum sets and a set of tests. Now, just to explain what a set of tests is, a set of tests in the context of a semi-detached dwelling usually typically includes a ground floor room-to-room test and a first floor room-to-room test, and that would be essentially a set of tests. In relation to apartments then and duplex dwellings, you can see that there's a lot more testing involved. There's six shown there in terms of the types of dwellings, and the next slide probably explains it a little bit better. In relation to a set of tests, what it says is, for a semi-detached or terraced home, that it would consist of a test across a ground floor and a first floor room. So a set of tests are 2 tests within that property. You'll see then for apartments, and as explained earlier, showed in the earlier slides, you saw the apartment arrangement, and I did say to you that it's a lot more complex. But generally for apartments, you're looking at 2 sets of horizontal tests across a separating wall. Again, now they're airborne tests. Again, you're looking at 2 vertical airborne tests across a separating floor. That should be floor there. I just realized that spotted that error. But so again, so it's 2 airborne on a separating wall, 2 airborne on a separating floor, and again, you need to also carry out 2 impact noise tests on the separating floor. So just keep that in mind. Going back to the slide, or the guidance in technical guidance document E, you can see they're talking about 2 tests in that scenario and 6 tests when it comes to apartments or duplex dwellings. So I'll move on to the next slide. So then, in terms of technical guidance document E, it sets out 4 wall types, or suggested wall types, that can be used. Now, I just need to highlight again the importance of considering the junction detail. Keep in mind the diagrams that you see here with wall types 1, 2, 3, and 4, they are only one element of the sound insulation test. As I explained to you earlier, it's a room-to-room test. So you're dealing with both direct paths through the wall and indeed flanking paths around the walls, and indeed any other path it can take. But again, the wall is only one element of it. So there are a lot of very good supporting diagrams in technical guidance document E in terms of how those flanking walls are integrated with the separating wall. So remember, when you're looking at the wall types here, for example, these would give a good indication of how they're likely to perform in terms of sound traveling through the wall, but it's around the wall you need to be very careful about as well. Again, in terms of technical guidance document E, it sets out three different floor types, floor type 1, 2, and 3. And again, I need to obviously explain that the junction detail is critical as well in terms of floors. I'm only showing you the floor element. And again, this is only one part of the picture, but you can see from the tests, because they're a room-to-room test, the flanking detail is absolutely critical as well. So in terms of how much testing, well, there's a table in Technical Guidance Document E, Table 3A. So the idea behind it is that in scenarios where you're following the detail in Technical Guidance Document E, i.e. you're following a wall type in Technical Guidance Document E, or indeed a floor type in Technical Guidance Document E, there are a set of tests required. It sets out in the Table 3A how much tests are required. So suppose you're building a terrace of 4 houses, for example. So the Table 3A suggests in that scenario that you carry out at least one set of tests. Now, with that set of tests, you're typically looking at a ground floor or a first floor test. Now, in a scenario where it's a terrace of a bungalow terrace, you're obviously looking at 2 tests across the party wall in 2 rooms, perhaps the front and the back of the house. But just the important thing is that Table 3A sets out, depending on the number of dwellings that you're planning to construct, and indeed the types of dwellings, which we won't have time to go into in detail here, but essentially it's setting out a sort of a minimum number of tests that need to be carried out. And Table 3A is specifically related to scenarios where you're following the guidance in Technical Guidance Document E, the build-ups, the wall types and the floor types in there. So again, it is only applicable to the construction types in Section 3 and Section 4 of the guidance document. So what if you don't follow the guidance document, Technical Guidance Document E, you decide to use your own floor type? Now, I just clarify here that I'm not suggesting that either of those pictures show a detail that would be likely to meet the minimum requirements in Technical Guidance Document E in terms of sound insulation performance. But the only reason I'm showing them is that what if you deviate from them, and what happens then? Now, keep in mind, these are not details that anyone should use in terms of building residential dwellings, for example, either for a party wall or indeed a party floor, but I just said I'd throw them in there anyway. But Technical Guidance Document E would describe something like those as another construction. These are deemed to be other constructions or other construction types. So there's a table in Technical Guidance Document E, Table 3B. It's titled Other Constructions. Now you'll notice with this table, there is a lot more testing required. So when somebody deviates from the guidance or from the wall types or floor types in Technical Guidance Document E, you need to do a lot more testing to prove that what you're using will be sufficient to meet the performance requirements in Technical Guidance Document E. So just let's say the first 8 dwellings are part thereof, essentially at least one set of tests for each separating element. So again, within this, they're looking for a lot more testing. Basically, you haven't used a detail that's in Technical Guidance Document E. So it does actually allow you to use different floor types, but it just means that you need to do an awful lot more testing to prove that it meets the minimum performance requirements. Now, keep in mind the amount of tests required are there based on the assumption that you don't have any failures either. Obviously, if you have a failure, there's a whole protocol around that and the number of tests that need to be required and after that and repeated and so on. So there's a whole series of actions, but in terms of if a wall doesn't meet the performance value, in terms of it may be upgraded, you may retest and so on. But again, we won't have time to run through all of that in this presentation. There's quite a bit in that as well. But just to highlight that those table 3A and table 3B are based on the assumption that there are no failures as such. Okay, so within Technical Guidance Document E then, this is the section on reverberation control. Now, just to explain reverberation is like echo. And if if any of you have been in some of the older apartment buildings and stairwells that often have very hard surfaces, they might have durable tiles and hard plastered walls, and there can be a lot of sort of echo in these spaces. So what happens in a space like that, if you've ever been in a stairwell, we'll say that's highly reverberant or highly echoey, you know, you get sound buildup in those spaces. And you can hear people, you know, somebody at the top of the stairwell, you can hear them perfectly well at the bottom of the stairwell. So sound carries very efficiently in these spaces. So it's generally deemed to be a sort of an undesirable effect for lots of reasons, but in terms of the building regulations, one of the concerns is around the propagation of noise over corridors. So for example, if you think of a hallway outside, say several apartments, say 10 apartments, the last thing you want is, I suppose, a buildup of noise in those areas, you know, so people using those spaces, there's a certain amount of absorption in those spaces, and that the spaces are deadened in some regards, so that it doesn't propagate as far along those areas. So again, section 5 of technical guidance document E talks about reverberation of the areas, we'll say outside the dwelling. And again, this was something new that was introduced in 2014. So there's two methods that are called up. One, we'll say, method A, we'll say, specifically used for entrance halls, corridors, hallways, and stairways. Method B then is intended for corridors, hallways, entrance halls, and it's not suited to stairwells. But again, there's two methods there. There's a simplified method where which is called method A, which essentially says that absorbent material should cover an area equal to or greater than the floor area with a class C absorber. Now, just to explain classifications in terms of absorbers, a class A absorber would be a very a high performing absorption. So when you're going out to buy, for example, a ceiling tile, they have different classifications. So class A would be the highest absorption standard, class B would be a bit lower, class C would be lower again, class D and class E. So they are all class. But what the building regulations calls up or suggests that essentially that, you know, you need to install an equivalent area of a class C absorber equal to or greater than the floor area of the space, for example, be it a corridor or indeed a hallway and so on. Then there's method B, which is in lots of cases, it may not always be possible to install, for example, the aesthetics of ceiling tiles in a high-end apartment block may not look particularly well, and in some cases you have alternative methods. You can obviously predict the likely reverberation time. You can specify treatments and so on. So method B allows for that. So in terms of a noise consultant being involved, one of the things you might be asked to do is to do a prediction in relation to that and determine, well, what if we don't do this? What if we do this? So we'd often work with developers in terms of looking at the surface finishes or the treatments that are planned for the common areas, and look at obviously ways of reducing the reverberation time in terms of satisfying the technical guidance document E. Okay, so this is just an example, photograph of a class C absorber over an equivalent area of a floor. So you might have a number of apartments along here on this side. Again, keep in mind, carpet has a certain amount of absorption, but again, in this particular scenario, ceiling tiles equivalent in area, just to show you that the idea of just installing absorbers of an equivalent area, I suppose, in terms of a floor area. Again, I explained to you that, you know, these spaces like stair cores and all of those areas can be highly reverberant. Again, in a high-end apartment block, you know, they generally would require, you know, absorption to be installed. And again, that can be, in terms of floor area, that might be difficult in some cases, but again, it's a factor that needs to be considered. And it's part of technical guidance document E. So nearly the last slide, then you'll be happy to know I'm near the end. In terms of competence, I suppose you know, it's important, you know, in terms of somebody who's shown how to carry out a sound insulation test, it's important to highlight that doesn't give them any competence in terms of giving you advice and our building design advice. Being able to carry out a test is something that you can train somebody to do. But in terms of understanding the acoustics of the reason or the theory behind a modification. So for example, let's paint this scenario, carry out a sound insulation test and the wall fails to meet the performance value. The next thing someone is going to need is advice. You know, what do we do now? How do we improve the situation? So I suppose the engagement of a qualified noise consultant means that they are qualified to give you that advice. So that's an important distinction to make between, I suppose, somebody who just simply carries out sound insulation tests and somebody actually who can advise you on remedial works. The other thing I would always advise people to do is, I suppose, to check those carrying out sound insulation tests of formal qualifications in acoustics, the necessary CPD and experience in the area. Again, that is something that should be sought when you're getting a sound insulation test carried out or appointing somebody to do it. It's important to have formal qualifications in building acoustics. And as I said to you, this is absolutely essential in terms of giving advice. Keep in mind, you know, when you hire a qualified noise consultant, you know, they carry professional indemnity cover. They are qualified to give you advice on what remedial works you should take and so on. So that's an important element I just want to convey to you in terms of confidence. So I think that's pretty much it. And if anyone has any questions, I'd be happy to try and answer them if I can. I'm just going to put my contact details on screen there as well. I'll try and answer them if I can. And as a last note, I would always say to you is always refer to the guidance and technical guidance document E and consult with your building control department if there's any uncertainty about any element in that. So thank you for that. And I might hand it back to you now, Shirley, if I can.
Yeah, that's great. Thanks a million, Dermot. We have just 3 questions here that I can see.
Okay.
If you want, I can read them out for you.
That'd be great. Yeah. Yeah, sure.
So why do you not test for sound transfer from ground floor in one semi-detached house to the 4th floor in the adjacent house, as this has been an ongoing issue?
It's a good question, but why don't we do that? Well, I would expect so I would expect with the test in that direction, for example, with the test in that direction, I would expect the performance should be marginally better in the diagonal than it should be in the horizontal, if that makes sense. The tests are essentially, I suppose, room to room tests. The separating element in a diagonal arrangement like the question that was raised, in a diagonal arrangement, the common area between we'll say the room at the ground floor and the 1st floor really is only a sort of a junction detail and small in area. I would have thought that the performance would be significantly better in that direction than it would be from room to room, either at ground floor to ground floor or 1st floor to 1st floor. But again, we're following particular standards, I suppose, in guidance, and the guidance generally is that it's a horizontal test. So I hope that answers the question.
Yeah, that's great.
Yeah.
The next one here would be just someone is saying thanks for the well-presented presentation, and they're asking for some guidance tips really on floor junctions where joist hangers are fixed into the partial wall.
To be honest, that's probably it's probably a little bit more detail than we could cover in this, and maybe it's something
we can come back We can answer that later on, and we'll put it up under the video.
But one thing I would say though, no matter what you're doing in terms of detail, I think it's critical to refer back to the guidance document. Generally, would tell most people that, you know, if you follow the guidance document, or the detail in there, that'd be my advice in most cases. But yeah, I can try and address that offline if that helps.
That's perfect.
Yeah.
If you want, I can read out a couple more, or do you want to just answer them all after, and we'll put them under the video?
Yeah, I can do what yeah, we can answer them afterwards. That's if there's a few in it. Yeah, I mean, there are probably specific questions there. I just see some there now. For example, under what floor type, you know, there's questions there about a 65 mil floating screed and so on. Look, they're probably, I suppose, they're technical inquiries that I would be probably best to look at offline if
that's fine.
If
Yeah,
makes sense.
that's perfect.
Yeah.
Okay. Grand. So we'll probably finish up. So I'm just going to share my screen. If you could stop there.
Yeah, absolutely. Yeah, I'll do that now. Yeah, apologies. I'll just get there now. Yep, there you go. Okay, great.
Grand. So you can see my presentation up there, can you?
Yep.
Yeah, perfect. So we have a number of events as outlined on the slide coming up. Live events will be circulated with Eventbrite, and recordings will be on our NBCO YouTube channel, which is NBCO TCC. I'd ask that if everyone can follow the National Building Control Office on Eventbrite, and once you follow us on Eventbrite, you will receive email notifications on future events and webinars. Dermot, I'd like to take this opportunity to thank you for your time today. It's great feedback so far we have in the chat there on your presentation. And I'd also like to thank the team here at the NBCO for organising the webinar, and in particular, Aina and Mairead.
That's great, yep.
That's the end there. As I said, I'm going to upload the video onto YouTube probably by tomorrow. And once we have all questions answered, I will be adding them under the description of the video on YouTube. I will send an email around with a video link for the YouTube video to all attendees here today. Thanks all for your attendance. Take care and goodbye.
That's great. Thank you, Shirley. Thank you.